Thank you. Does this still work?
Yeah.
Okay.
Should be. Yeah, that should work.
Okay.
Good try.
Hello.
Yeah.
Hello. It works. So, hi everyone. Good evening again. My name is Vikas. Vikas Pandey. Vic Pandey is my GitHub, Stack Overflow, Gitter, LinkedIn account if you want to connect. And I'm working as a solution architect with Leopard. Leopard is a blockchain company that helps its customer develop blockchain solutions. And we are also developing a lot of APIs that can be consumed by developers and build a blockchain platform for themselves. Something about Leopard. Like I said, we've been working in this space for quite some time, and we have a team of international engineers working across location. And that's what we say, that we work on a distributed technology, and we have a really distributed team. I'll come to the details later. Yeah, it was started in Amsterdam by Jeroen van Mechelen. It's a tough surname. He's been into blockchain for the last 2+ years. He's a technologist himself, so he's the chief technology officer as well as the chief executive officer of the company. And we have an international team of 40+ developers, close to 50 now. So Jeroen started blockchain as an extension to his Tagologic company, which was more about creating tags. Like we have a barcode scanner, and he happens to be one of the inventors also of one of the barcodes. And from there, he started hashing the barcodes and the transactions, and then he said, okay, now I should move towards the blockchain technology. So we have a team in Russia. We have a team in Amsterdam. Amsterdam happens to be our head office. We have a team in The Hague. We have a team in India. And altogether, we are a team of 40 people. Yeah, why should anybody use our platform? So there are multiple reasons. Like we heard in our previous talk, people want to open up their APIs as well for people to make developing blockchain easy. And we really believe in the open source thinking, because a lot of things in the blockchain also comes from the distributed, the Linux kernel development, as you know, from the peer-to-peer network concept. So we also live the distributed and open source thinking. And we've developed quite a bit of APIs that can be used by companies and developers to make their own solution. We'll talk about the details in the later slides. Yeah, and like I said, when you go to these conferences and to these meetups and hackathons, you see people really struggling with a lot of the early stage development and trying to figure out the same problems that we saw, like reinventing the wheel and doing a lot of trial and test. So we thought, why not provide a platform which people can use and develop solutions faster? So yeah, you can use most of our APIs and services, and you don't have to do the heavy lifting. Yeah, we also won some sales kind of a slide. We also won some Computable Award 2017 as one of the most innovative companies in Netherlands. We also got some award this year, but let's keep that for the sales part. Yeah, and we have services which are being used in production. So I just spoke to one of my colleagues here, and I was showing him the kind of application that we have developed for our customers. We'll also talk about that later in detail. And as an extension, I also spoke to Walter, the organizer, that if anybody is interested to see how a blockchain works in real production environment, you can feel free, talk to me. I can show you applications, mobile application, web applications, and how do they work in production and the experiences out of it. So our solution. So yeah, of course, like I said, we really believe in the decentralized economy and the open source, and that's why we chose Ethereum, because of all the known reasons. We all know about it because of the early stage development that it went through in the blockchain world, the speed, yeah, in private blockchain, yes, and also the different services that you have and the maturity of the Ethereum platform today. And we have 3 solutions we call Ledger Leopard Chain, which is like a public chain where you can use our APIs and develop your own, and the nodes as well, with which you can develop your own solutions. And then we also have a list of API libraries. We'll talk about those in detail in the next slides. And then we also do custom development, because that's where we get our money from, right, to survive. So we also build solutions for our customers and also try to look at it from a problem perspective. How do we solve the challenges and the problems of our customers and the industry? Any questions so far? Or are we good? Okay. So Ledger Leopard chain. So like I said, we have a public chain and a private chain. So in public chain, you have a list of nodes that you can use and consume, and you also have a lot of APIs from us, like the permission layer, notifications, and other APIs that you can use and consume to develop your own blockchain solution. And we also have created private blockchains, of course, for our customers, where we develop multiple nodes for them, build different services depending upon the use case of blockchain, and then we ship it to the customers. So API library, this is a heavy slide. So we have quite a lot of APIs. Let's start with the sign up and sign in. So for authorization and authentication, the user management, hashing of the users, the transaction that the user does. So we have a sign up API which you can use for authorization and authentication. Next, we have a permissions API, which is to create a different permission structure. Like we heard in the previous talk, what level of access or permission do you want to give to different users? You do not want every user to have every level of access, which is also coming from the traditional software development world, right? You want administrator to have the godlike access, whereas you want participants to have a different level of access. Invoices, most of the use cases that you see, because we are talking supply chain, at the end of the cycle, you want to generate invoices that the customers can use and make payments. So we have invoices API. We also use ERC20 tokens from Ethereum to create wallets, from where you can create virtual coins, which can be used to transact between different, which can be used as a currency for transactions. And we also have a transactions API where all the transactions are logged in hashes, and they are created in blocks. And these transactions also have things like what was the subject of the transaction, who initiated it, which block does it belong to, what is the hash created out of the transaction. So you can use it for that as well. File upload API, very self-explanatory. If you want to upload a file, that also creates a new hash, and that also gets registered into the Parity network. Notification API to create notifications about your transactions. And we also have mobile libraries. So that was the last use case that we recently developed for one of our customers, where you can use our mobile library to also use blockchain solutions in a handheld device, like for iOS and Android. Please stop me if you have any questions anywhere. And we also have we also do custom development for a lot of our customers. Well, 8 of them, not many. And we'll talk about them in detail later on. And we have experience in a variety of fields, or domain as we call it. We are very heavy on the healthcare side. That's how Ledger Leopard was born. We started with a very RTL famous, media famous partnership we did with one of the maternity care in Netherlands. And we'll talk about that app later in the slide. And we are also doing a lot of projects with research institutes in the Netherlands. We are also doing projects for hospitals, for the healthcare providers. And we also work with the building management solutions, which is like the whole facility management, where you want to track your all the things in the building, like Internet of Things, along with blockchain. How do you hash them, do the track and trace part of it. Asset management, again, tracking your entire asset that you have in the chain and making sure that you do not lose the track of those assets. So these are small proof of concept use cases. We do not have anything in production yet with these two domains, but we have quite a lot of application on the healthcare and the finance area. So the last is, of course, finance. Okay, so what we did, like we heard in the previous talk, we have a lot of challenges when you start developing blockchain applications. And when you go to a customer saying that I can develop a blockchain solution for you, they're like, okay, but are you good enough? So what we did is, what the CEO did smartly enough, he went to TU Delft saying that, can you please validate our solution in terms of the code, the software architecture, and TNO is another University of Applied Sciences or something in the Netherlands that also validates, institute that validates whether the quality of your product is good or not. And then this is another firm called Pels Rijke, if I spell that right, which also looks at your overall governance, security, and the privacy of your organization. So the CEO went to these institutes, got the whole solution verified in the organization, and then we also took a certificate from them so that we could take it to our customers saying that, we have a solution which is good enough that can be used and taken to production. Yeah, and that's what is our differentiator currently as compared to other competitors, if I would say. Yeah, this is a slide that I want to share, not a part of what we developed, but I always try to share it with everyone to give a background. So blockchain 1.0 was mostly about cryptocurrencies, right, that we heard, all of us. And then there was a blockchain 2.0 where people started writing smart contracts around it. And then there was an evolution of blockchain 3.0 where you had decentralized applications which had smart contracts written into it. And we are currently sitting somewhere between this and this stage where in blockchain 4.0, where you see companies trying blockchain to solve one of the problem cases in their industries, whether be it healthcare, airline, or finance, or things like that. So yeah, we also believe that we are somewhere sitting in the blockchain 4.0 space where we have tried a few applications in production. We are also learning like the whole industry, and we have some learnings out of it and use cases that we take it to our customers and share with them and co-create solutions. So the healthcare, like I said, I work on the healthcare side because I believe it also gives a very good dimension when you work for the healthcare, adding value to the thingy. So Zog Institute is the use case that we are going to talk today. I also have a short video we created for the RTL news channel. They wanted to promote it, and also we wanted to promote it in the media, saying that we are doing something in healthcare in the Netherlands. And I'm going to talk about that later on, where we talk about the distributed ledger, the invoices that we generate, and the wallet that was created in it. The second use case is Isala. So Isala is a big healthcare, non-academic healthcare hospital, in heart hospital in Zola. And they have a lot of doctors and smaller clinics under their umbrella. And every time a patient goes to the hospital, he has to go through multiple doctors before he can be approved by these doctors that he can go through a surgery. So there's a lot of parties involved in that. A consensus needs to be done, and all of those needs to be tracked into a system. And now it happens in a lot of silos. So that's what we created, a consensus, a notification, and a document upload mechanism where doctors can see the reports and feedback from the other doctors and eventually do the surgery. Doutbout is an initiative that we did, and I also have a working applications for all these case studies that I'm talking about. Like I said, if you want, we can discuss it and see it later. So Radboud is a university in Nijmegen, and what we did with them is we created a module which is also used by hospitals, where you can, as a patient, you can say that I allow access to my data from this date to this date. So you can go to a mobile app and you say that as a patient, I allow access to this hospital or the other hospital from this date until this date. And then a log is generated out of it, so you have the control and data permission layer there, and you have a logging service as well there. For example, if you want to go for a treatment and you give all your data to the hospital, you do not want that data to stay with the hospital after a certain point of time. So you can really define the timeline where you can say that from this date to this date you can access my data, and then you stop it. Plurine, again, is a healthcare provider that treats mentally and physically disabled patients. And the use case there was like when a physically or mentally disabled patient goes to the hospital, he has to keep on telling his story from every hospital to the next hospital he goes. And we wanted to create a decentralized ledger where all these doctors had access and information about the patient even before he reached the hospital, and also creating appointments for him. So that was also like creating a very smooth process for a person who's not physically or mentally equipped to give information every time and kill the wait time there. ICT for Cram, this is a company that does a lot of ICT for the healthcare industry, and they also wanted to try something with us with regard to the blockchain. So this again is an MVP that is still being tested. It's not in production yet, but we have a proof case that we can show you, where we are doing planning for nurses. So if a nurse wants to make herself available for service, let's say for a particular week. So as a doctor or as a patient, I can go to Google, I can look for a nurse, set up appointment, and look who's the closest nurse to me in terms of availability and reach. For example, for somebody's parent who's really old and you want an immediate service, you can go to Google using the Google API. You can take the service of a nurse nearby who's agreed to be in that ecosystem. And we have wallets with which you can use, with which you can pay for your services, again based on ERC20 tokens. And of course, you can generate invoices. Once the nurse provides the service, she can send invoice, and that gets paid by the patient or the insurance company. Okay, so when we started the first project, which was the Zog Institute, we saw a lot of challenges, like we all know in the blockchain industry, which were like, there was data which was not reliable. People were tampering data, or the data was outdated. So you have a lot of people approved something and they didn't agree that they approved it, or it was not visible. So the whole immutability and the irrefutable part of it is a problem. And in the Netherlands healthcare ecosystem, you have a lot of data silos where you have some information sitting with the laboratory, some information sitting with one hospital, the other with the other hospitals. So we also wanted to create a more decentralized but a more central ecosystem where everybody could check it. And of course, the transactions coming out of it, tracking of the transactions. So transparency of the whole supply chain process. So in terms of transparency, a patient doesn't know what is happening with his data. A patient doesn't know if something is being logged and where does it go. And another thing also is a patient or a hospital doesn't know from which date till which date his information is being used or not being used. So that is another thing that can also be provided based on the use case. Inefficiency. We all know we can eliminate a lot of inefficiency in the whole supply chain process from the moment a patient goes to the hospital or a nurse provides service until the nurse gets paid, with a lot of automation and writing the whole agreement between multiple parties in a smart contract. Control. So like I said, the route-bound use case where you, as a patient, you can decide how much of data you want to expose and from which day to which day. So that's another thing that we also wanted to overcome with the healthcare ecosystem. I want to show a demo of not the demo, it's a video that we created for the application we built. So this talks about the remaining of my presentation in like 1.5 minutes, but I'll still show you the application in screenshots after the video. The audio is still not there. Yeah. ATL, right?
Yeah, that should be it. Definitely. Let me try here. It's already on, right?
Yeah.
Okay. I just use the internal speakers, put your mic.
Yeah.
Where's the speaker?
Chain. Maternity nurses fill in timesheets that they get approved by the parents. The
Should work.
Yeah.
maternity care office then processes these timesheets in their system and then sends
Can
them
you guys
to the
hear it?
insurance company. The insurance company then enters the data in their system. The maternity care office does not receive payment for the care until 90 days later. It is a process with many downsides. The parents have very little control, while the administrative process is time-consuming, inefficient, and drives up costs. That is why health insurance company VGZ and the Dutch National Healthcare Institute asked Leopard if there's a better way to do things. Using blockchain technology.
But that's fine. We
Insured
have
patients are given an
the
app that
subtitles.
contains a blockchain wallet. That wallet gives them a number of maternity care hours to spend on a maternity care nurse. At the end of every day, the parents receive a notification. If the parent selects Do Not Approve, This directly prompts discussion at the source as to why a certain service was not provided or not provided to their satisfaction. If the parent does enter an approval, the source has already confirmed that the service was provided, and it is then irrefutably entered on the blockchain. The insurance company pays the maternity care office directly from the parent's wallet. In short, the process can be directly checked by the parents, all parties work together in one system, and the invoice is no longer leading. Instead, it is a direct result of the process. The maternity care blockchain. Clear, straightforward, and efficient.
Sorry about the audio. Couldn't help it. So, like you saw, there are multiple applications of blockchain in this implementation where you create wallets for the nurses and for the parents, and there are transactions that are being logged into the blockchain, and then there's also a consensus or an approval mechanism which is also being logged into the blockchain where if a nurse provides some service, she sends an invoice against which the parents can say that, yes, she did provide this service to me, and then they can approve it. And once it's approved, it goes to the insurance company from which the nurses get paid into their wallet. And these wallets have been given as hours, as we call it, which is the cryptocurrency we used in this case. And these hours can be translated into euros. And the agreement between all the parties was like every hour translates into every euro. And these hours were eventually being paid to the nurses as and when they wanted. And like you saw also in the video, in the previous process, the nurse has to go to a parent's place and provide the service to the baby, and then she has to take the whole information in a piece of paper or in an app. And from there, she has to go to the insurance company and the healthcare provider saying that I provided this service. And after a long period of time, normally it is, on an average, it's 90 days. After 90 days, the insurance company or the healthcare provider calls up the parent saying that this nurse provided this hours of service. Do you confirm? And they were like, yeah, we do, but we don't remember it well, and they don't remember the hours. So there are scope where you say 8 hours instead of 6 hours and things like that. And yeah, that's what we tried to solve with this MVP. And along with the Zog Institute, we did this MVP in November, and it was then approved to build into a product that is now currently being used by a couple of hospitals. And from there on, we saw a lot of challenges like the planning part, the consensus part, and then we picked up the other modules and started developing it also for other customers. Any questions on that? Yes. Yes, you did. Yeah, that's a good question. You need blockchains for multiple reasons. One is to track whether the nurse provided the service for that particular baby. So you want to. I'm coming there. I'm coming there. So now, if you have a transaction being tracked into a blockchain, then you have a lot of parties also being involved, right? So for any blockchain transaction, there are multiple use cases. One is like the provenance. You want to understand who initiated this particular thing, and that gets also tracked into the system, so that no unknown party gets involved into the process. So the scope of hacking a transaction or hacking logging as an unknown user is almost minimal. And as we know that since the Bitcoin days, the Bitcoin blockchain ecosystem was never hacked as compared to any other system. Now there are multiple parties, like you also said. There are multiple parties, and you want all of these parties to work on a distributed ledger where they all speak the same language. Like I said, there are different data silos sitting with different parties, and you want to bring all of them together. Where when I feed something into the system, you also get access to that. The third use case, again, is the distributed nodes, right? Like I said earlier also, where you want to have the service available. So if somebody attacks a part of your node, it still gets replicated across other nodes and brings up your service, and it is more available. So, yeah. But that's a good question. Sorry, any other questions? Yes, please.
What if the user doesn't want to use
Yeah, this was, like I said, a use case. So as a user, you can say that I don't need a wallet, but in that case, you'll have to pay it with a payment, like with a typical fiat-based money, or you want uh, a payment gateway integrated into it. So there has to be a payment at the end of the cycle.
Okay.
So,
I have a question about something a couple slides back.
yeah.
You mentioned, no, it's way too far back.
Okay, okay.
You mentioned uploading files to blockchain. Do you upload a reference or do you hash? Okay.
Yeah, we do upload the hashes and the references. Yeah, because like you also know, most of us would know, like uploading files can be exactly the whole performance and storage and good one there as well. Any other questions? Or so what I'm going to do next is I'm going to show the same app with a very small use case of how a patient logs into the, or a parent logs into the app and then requests for a service to a nurse, and then the nurse logs in with her username and password, and she has her own different permissions, access and everything, and then she, after she provides the service, she sends an invoice to the parents, and then the parent logs in again and says that, okay, this moment, this service are provided, this is the attachment I see, and I approve this service. So API is the parent that opens the app. So it's a very simple login. Then you go to this interface. This is a mobile app. And then you have this user, and then you say that you can do administration there. And there are all the different profiles that are created. In this case, this is the service provider, Caroline. Yeah, this one. And then in the permissions, you can go and see that you want to give permission to Caroline, who's your approved or agreed nurse in this case. And then you can see that she can read and write. I know it by heart now. Lesen and Scriven is read and write, the information that you want her to access. And once you set it up, then you go to the Zog Balance. This is something which I said you get tokens out of it, and you're given a set of tokens at the beginning. In the maternity care, it is 49 hours of service that you get from the government by default. So we translated those 49 hours to 49 tokens that you get. And every hour that the nurse spends, she gets 1 hours of token against it. So we really translated into hours and tokens to keep it simple. You can, of course, do it also with an ICO, but we wanted to keep it simple. And then from there, you see all the tokens that you have in your wallet. And this is the profile where you can do it using a different mechanism. You either put it into the system, or you can also use the Barcats corner. That's also something that is built by our company. And you fill all the information in there about yourself. And then this is the invoices, facturing. Yeah, these are the invoices. And then and these are like all the documents that have been received and that has been sent by the user. And then in the My Log, you see that you have requested for some service from this particular nurse, and then you create a document around it. What service do you need, and what she needs to provide, for which date, with all the details in the document. And then you say the details of the service again. And then you say this part, the user, API, and then the service that is requesting for. And then this person logs out, and Caroline, in this case, is the nurse that is going to provide service from the healthcare provider. She logs in with the app because the request has been created. She gets a notification in her app. And then she logs in and looks at her logs. And then she sees that there's a new service which has been requested by API Janssen. And she selects it, and then she sees that there is this service that she has to provide to API or his kid. And then these are the details. What are the details about the service? How many hours is requested, and things like that. And from there, once she does that, she creates new invoices, and these are the list of invoices that she requested earlier and that was accepted. And then here she adds the name of the users, how much time of service she provided. Then you also see different categories here, like for which type of service, how many hours, and how many points against those services. And then she requests for it, and you see the status here. It's for Epi unsent, 2 points, 2 hours, and it's waiting. And it was created today, 14:13. And then the parent, in this case, opens the app again, and then it's a very natural cycle, right? He goes there, looks at it, like, okay, she provided service. I had 50 for 1,000 Zog. I had 50 points, and now I've received a new invoice from this lady, Caroline, that I requested. She provided the service to me on this date, and the details there, and then he accepts it. And once he accepts it, he goes and sees that 2 points out of the 50 gets deducted, and that goes into the account of Caroline. She logs in again, she gets notification, and against that she can go and give it to the insurance provider, get her money back.
Like with both the client and the nurser can put in, right?
The client can request for a service,
Yeah.
and the nurse will send an invoice after she provides the service. So they all have their own wallets, and when a parent signs up with an insurance provider in the Netherlands, you get 49 hours of service, and that 49 hours is nothing but 49 tokens or hours points that you get. And you can use that 49 in a certain period of time and multiple times with the different nurses that can provide service.
And can you transfer these points to other users as well, so that you not use them yourself, but donate them to?
You can also donate them, yeah, exactly. And like I said, there are multiple parties. This is a use case only for 2 participants. Then you have the healthcare provider, the insurer, and if you don't use it, then it gets transferred again. So it's also like 49 hours of service that you get from the government, and you don't use 49 hours, so you don't get anything against it. So it's
Then you can transfer. I can transfer to the neighbor and say.
oh, not to the neighbor, not to the neighbor. It goes back to the insurance company. Oh, I thought he said that. No, no, you cannot. Because that neighbor is not in the participants' ecosystem anyway.
If he would be, could I or not?
No, currently it doesn't support. And I think legally also you cannot do that.
So is this on a public chain or a private?
It's a private chain, yeah.
So who owns that chain?
So currently it's owned by Zorginstituut. It's an institute in Diemen. Yeah.
Okay, so they are controlling the whole
Yeah,
system.
yeah.
One party you have to trust in this.
Yeah, exactly. So when we set up the whole system, we are the technology partners, and we also did solution with them. So for all setup and everything, access, administration, we set it up for them, and then we hand it over to them.
Right. Okay.
So
You mentioned you also offer a public chain?
yeah, we do.
Different one from the mainnet?
Yeah, we do.
And that's the one you own?
Yeah, that's the one we own, where you can consume different services, like I said, permissions, notifications, sign in, sign out, sign up services, authentication, to name a few.
Yeah, right. So in that case, you're the trusted partner.
Yeah. Any other questions? Yes, please.
Could you have built this without blockchain?
Sorry? Yes? Okay, you said yes? Okay. Yeah, of course you could do it, but now you see there are a lot of things, like I also answered to the lady here. There are a lot of data silos. And how do you trust when you make this distributed ledger of these data silos by making sure that you bring all the participants in the transaction with their identities, their permissions, and what transactions they do. So that's one part. And like I also said, the whole availability of the different nodes that we have. So the typical immutable, the track and trace benefits of blockchain is what you get out of it. So long story short, you can still do it, but it will still not be the most efficient one. Like, it's not that nobody has a digital application for this kind of service. There are players, but you do not get the whole speed and benefits that I'll also talk about later in the slide.
Another question.
Yes.
How do you ensure GDPR compliance? That's the whole topic this week.
Yeah, so like I said, we are not ready yet, very honest answer. But like I said, most of the data, we have a permission layer now, where you can say that I provide this data from this date to this date. So that's a new module we have built along with Radboud University. That's something that we also intend to put in all our applications. Of course, that's just one part of the GDPR equation, but we also are planning for ISO 27001, which takes care of the bigger security and data compliance ecosystem.
Yeah, so that's controlling access.
Yeah.
You have a means to actually erase data of the clients.
No, we do not have the authority, because it's mostly like in this case, you either Zorginstituut or in other cases, Isala, the healthcare provider. So they are the people who have to decide for themselves. They can do so if they want. So that's not on our plate, honestly, because we are the technology providers.
Yeah, because typically blockchain technology is censorship resistant. It's difficult to erase data from the blockchain.
Yeah, I agree. But I don't know if it is about erasing data. It's also about, like I said, the module that we created. You can still access data from a particular date to an end date, right? And you are really not putting the data, the name, username, and other things of the customer. You are really putting the hashes in the blockchain, right? So as a user, I get my my ABI code that comes out of the blockchain, like with the big digit number.
So the actual system does not store any personal data.
We have MongoDB that stores the data in the databases, but that's, again, like I said, you have to flush it or do it. But we have not solved that equation yet.
So you're depending also on a separate data source.
Yeah. Yeah, indeed.
Who has able access the database, the backend?
Currently, it is the technology team, and yeah, from our side, it's the entire technology team, and then we have to go through the whole VOG process, we call it in the Netherlands, where they go through your character certificate and everything. So that's a typical process we have here. So that's no different. Any other questions? So like I said, so for the healthcare provider, it eliminates the data silos, right, with the distributed ledger implemented there. For the insurance company, like I said, the insurance company doesn't have to wait for 90 days until the whole process takes place, like the whole processing from the point the patient requests the service until the nurse gets paid for it. And the nurses, in this case, she can technically request for payment in 5 minutes. So we have also tested scenarios where she could get paid in 5 minutes as opposed to 90 days. So like I said also earlier, the parents can control the data. They can see the logs of what is happening and what is being done. So in most of the implementations that we do, we also take our solutions to the different parties and show them how those things get logged into the blockchain and how those are hashes which cannot be decoded. And even if it is hacked, then you just get the hashes and not get the patient details. And yeah, the whole tracking and irrefutable part of it is what all the parties get. On time. That's it. Thank you.